I'll wait for a few people to show up here. If you're already here, watching this on the replay, welcome along. Corner this, we are live. If anyone's here, let me know down in the comments. If anyone's here, let me know down in the comments. A little bit weird there if I keep wishing myself. Hello Beth, welcome along. Just checking that the chat box is working in the bottom left hand corner. Could just be you and me to kick off with Beth unless somebody else shows up. How was the biomechanics? That's tonight. Let's see if I can work out how to get that link working again. It's sort of working. How do I share this then? Settings, so on and so forth. Copy video URL. Tonight, see if I can work out how to get that link working again. Okay, back up to this bit. Try again. It's sort of working. How do I share this then? Settings. See if I can work out how to get that link working. Nope. Get some background audio with me speaking to myself. Not desirable. That's to show me about the biomechanics, Beth. That's what sometimes is the worry in terms of when people are on these random calls and webinars and so on and so forth, and you don't know who's showing up. Thanks very much for reporting on the link. Hopefully a few more will pop up in the chat. And once we get going, I'll give it another couple of minutes, and then I'll start talking through the ANOVA output, so we can all sort of see where we're going. Anything in here that shows me the number of people that are watching video at the moment? 16 viewers. Cool times. So hello everyone. Obviously this is a bit new for a lot of us. I'm trying a bit of software called Streamlabs, so I can sort of see who's here. I'm looking at the chat, so on and so forth, working out what's going on. but trying to work out what to look at, what to read. Interesting, let me put it that way. So overall, the objective of this session is just an opportunity for you guys to ask for help, an opportunity for you guys to ask questions in terms of how things are or are not going. Let me know any problems you've got. I can see the chat over here on the right hand side, so if you want to pop in any questions to that, more than welcome to try and answer them. I'll either type an answer or answer a question to the video. So I'll pick those off as they come up, in case you've got anything that is or is not working. I know that some of you are maybe struggling with the remote desktop. It is something to get used to. I think the biggest problem with it is sort of working out whether it will work quickly to start off with, which is not always the case. I tried to log on last night to do a little bit of stats in terms of preparing the results sections data for you, and I sat here for half an hour watching it in terms of working out whether it would eventually show up. I ended up switching over to JASP to try and do something, and then coming back into Excel after that. Then it showed up after half an hour. So I do appreciate that the remote desktop is not always easy. I've put a couple of links up on the Moodle page for you in terms of finding your data. So one of the problems with working remotely is that if you download something from the Moodle page, our natural reaction is just to double click it in off the downloads bar and expect it to open. And that doesn't quite work for the remote desktop. We'll sort of imagine you're on two separate computers would be a better way of it, describing how the desktop is working. So you've downloaded it on one computer, but actually SPSS is on another computer. So what you've got to do is you've got to work out on the computer with SPSS where you've saved it from. So I put a video up on the Moodle page. It's also up here on the YouTube channel for you guys in terms of sorting out where it is. The quickest method I found is to use the remote desktop and open up your H drive, which is in the UOC apps. And from there, you can then move things over from the Windows Explorer on your computer to the Windows Explorer on the H drive, which is the computer that you're working on with SPSS. So I found that to be the quickest way of moving files around. But for some of you, I also appreciate that the remote desktop is just not working. And that could be for some of you who are using Macs, it could be some of you using Google Chromebooks and those sorts of things. I think that there are options and workarounds for it. So you might need to download an app from the Google Play Store or something like that, or download the app from the App Store for Apple, and then work your way through the help guide that's on the Moodle page. Not Moodle page, the help page for how to set up remote apps. But at the same point, I've been playing with JASP, which is another software package, which can do exactly the same analysis that we would do in SPSS. I personally quite like the change-up. I've been using SPSS for a long time and quite enjoying how JASP does certain things in terms of how it does an analysis and how that analysis comes out and how it's presented. It's just that I'm got used to how SPSS moves along. Okay, so from what I can see, there's 27 viewers in the chat, so or 27 viewers watching this video. So let's just chat through the Excel output that we got here from the sprinting data. So because you guys have been through scientific inquiry, this is your data set from last year. So if you remember that data set, we collected warm-up data across the course of 2 weeks. In 1 week, you did the dynamic stretching. In the other week, you did the static stretching. And it depended on which class you were in the order that you completed things in. So what everyone did was we did the 5-minute jog, followed by the baseline testing, and then followed by the either static or dynamic stretching, which followed the rules of Perrier, Pavel, and Hoffman. And then we did some post-stretching. So this here is the sprint data that I'm looking at over here in terms of what we're looking at. And First thing to look at is the data did come from a normally distributed population. Now, down here, just make this a little bit larger so you can see what I'm pointing at, is we're right on the limits of 9.6, and then down here again, right on those limits again, which is one of the good things in terms of having criteria that got different authors suggesting different things. So I'd use plus or minus 2 here. Now, I'm not just doing that to sort of get on with it and use ANOVA. You'll read in some textbooks that talk about ANOVA being a statistically robust analysis. What that means is it can cope with violations in some of the assumptions, specifically normal distribution, especially when you're still pretty close to the criteria. If, however, we started to head well above 2 towards 2.58 and 3, that would be when I would pause for concern, check for outliers, and see what I can do with those sorts of things. So we'd carry on in this case because we're right on the borderlines. Happy to say it's normally distributed. Shapiro-Wilk down here also supporting this. Okay, so as I scroll down the output, I've decided to try and follow a bit of a color scheme. So if it's red, I'm chatting about some of the assumptions for our analysis. Here come the histograms and the QQ plots and the box plots as we're scrolling through. So you can sort of see how there is some hint of some positive skew, but not bad in terms of what the overall presentation of the analysis is. Outlier here, I had chased this down in SPSS and checked whether they're a significant outlier. They're not, they're well within the plus or minus in this 3.29. So, in terms of the analysis itself, this was a two-way ANOVA. And because everyone did every condition, that would be indicative that we would have a repeated measures design. So if we were trying to draw out the type of analysis, I'll just sort of write it out here. We'd have dynamic and we'd have static. And everyone did baseline / pre. Got an extra little character in there. Get rid of that one. And then we'd have a post-test. Okay, so as I would draw this out in terms of my own little diagrams, this would be a time variable which has two conditions. And because everyone was measured twice, I classed that as repeated measures. Now, this particular one here is our type of warm-up. Warm-up, and everyone did those as well, so therefore it also has two conditions, and that also is repeated measures. Now that would put us in the ballpark of considering the type of analysis that we'd need to do, and in this particular case we're two-way within subjects and evidence. We have repeated measures for both things over here. Okay, is everyone happy with that logic in terms of what you guys are looking at, and is everyone happy how I get there? Sort of leave a thumbs up in the comments. Do you feel like a YouTuber now if you follow the logic of what I'm talking about? Okay, so next steps was setting the data up in SPSS, and I think that's the trickiest bit in terms of a two-way within subjects ANOVA. The setup itself is tricky because you have to set up two within subjects factors, and those two within subjects factors you've got to think about the order that they're presented in terms of which factor goes in first, which factor goes in second, and then once it gets into SPSS, how that actually then moves things over. So the tricky bit is working out what the numbers mean when they come across. So when it comes over as factors in SPSS, I would have set up two factors in terms of my results. factor 1, the type of warm-up, was my first within subject factor, and factor 2 was my time variable, which should be the pre or the post. Now, because of how I set the data up, it allowed me to bring the data set up exactly as I ordered it, whereas if I put time in first, it'd have been a slightly different thing. And then as the numbers look in SPSS, it 1, 1 and then 1, 2 would relate to the different levels of conditions. So 1, 1 would relate to the dynamic pre, 1, 2 would relate to the dynamic post, and 2, 1 and 2, 2 relate to static pre and static post. So that's just a tricky bit in terms of working out how to set up a within subject factor. I know a few of you have got repeated measure designs with 2 repeated measures variables, so this is the thing that you'll have to think about and work your way through when it comes to doing your own analysis. So multivariate tests comes up next. As previously, just keep on scrolling by, because we don't need to worry about those, because we're not getting our results from those. Now, Maudsley's test of sphericity is still an assumption test. It is, however, an assumption test that we don't have to worry about today. The reason we don't have to worry about it today is because we only have 2 conditions of warm-up. We only have 2 conditions of time. And Maudsley's test needs 3 conditions within those main effects for us to actually have to worry about whether there is or is not sphericity. So in this particular case, I've highlighted it here. I can move on by and assume sphericity. So tests within subject's effects, this is where we get our results. And we have main effects for the warm-up, which we'd have to worry about. We have main effects for time, which we'd have to worry about. And down here is our interaction effect. Now, I've already been through this output once, because I don't think you really want to log onto a live stream and really watch me type. But here's the output values that I'll be highlighting within my main effects and within my interaction. Now, we can just assume sphericity across the board. So we're going to get our degrees of freedom from the sphericity assumed lines, and our F value, our probabilities, and our effect size values from over here. Same thing for time, same thing for the interaction. Now, by now, I think you're fairly familiar in terms of how I'd go about presenting the results, in terms of what I'm looking for in terms of a presentation of those particular results. But the tricky bit is to work out what they mean as we go through, specifically since the examples I've given you so far in class have all been significant for absolutely everything, and that makes life pretty easy in terms of just, well, I'm just going to do this and then I'm going to follow up with that. But when we have non-significant results, what does that mean, and how do we then proceed with them? Some things mean that we can do certain things, other things we need to pause, have a think about it, and work out whether it's actually necessary, which is one of the good things about the 2 different data sets that we've got here. So here's the result for the effect of warm-up. In this particular case, no effect. Now, what that means is that the warm-ups were not significantly different from each other, regardless of when we collected our data. And that's the tricky bit in terms of what it is. So the warm-up's actually pretty similar across the board. And I'll scroll down to the diagram in a minute in terms of what that means. But there's no difference in that effect. Now, how we can explain that is by looking at the graph down the bottom here, the marginal effects ones, is that when we actually look at how far apart the 2 types of warm-up are, and the blue one being the dynamic warm-up and the static one being static warm-up, those differences between the points in the baseline precondition not far enough apart to suggest that there'd be a difference. And then again, up here, the difference may or may not be far enough apart. We'll find that out when we get to discuss the t-test afterwards. So with that as a bit of a spoiler alert, we need to look again at what we get for the main effects of time. A large, significant main effect here. Again, just rules of thumb for you. If this value generally gets above 2, we're going to find a significant value. And being at 26, it's massive. The partial letter squared at 0.5, that's absolutely huge as well. in terms of massive and statistically significant. So there's a big difference in terms of the effect. If you remember looking at the graph just a second ago, the graph indicating that the two scores, both warm-ups, had increased. Now, I've said this previously with the other ANOVAs we've worked our way through. The interaction is the most interesting, usually because it shows how groups or conditions might respond differently over other conditions. And in this particular case, we've got a large, significant effect in terms of interaction. So the combination of the warm-ups, they've responded differently over time. And that links again to what this graph is showing to us. Now, I said to you when we first started talking about two ANOVAs, if you see a sort of triangle or crossing over of shapes, that is indicative that you've got an interaction. So what appears to have happened within our data is that the dynamic warm-up has increased, but at a slower rate or a lower rate of improvement than the static warm-up. Now, in this particular case, increasing is not a good thing, because with a 36.57 meter sprint, we actually really want you to get faster, so we'd actually like to see the times go in a different direction. So this is indicating that we've got an interaction effect, but not necessarily a positive interaction effect. And what I mean by positive, bad for an athlete. So static stretching has, following the warm-up, doing the static stretching has led to an increase in time, increase in their completion time, which is not great. Okay, so how would we proceed? Well, the interaction effect is the one that gives me the permission to do the follow-up test. So this is the result that pretty much trumps all the others in terms of what we're going to possibly do. So that's indicative of where I'd want to go and what I'd want to do. And then in terms of what that interaction effect is, what I'd be looking to do is do some form of analysis that compares pre to pre. I'm quietly hoping that they'd be pretty similar, because although we did baseline testing on 2 separate weeks, and there is a possibility when you do those things that baseline testing would lead to them being pretty much the same across stuff. And what I'd be quietly hoping for is that they would be the same each week. So I'd quite have liked the static to be, or the dynamic to be a little bit closer to this pre-stage if I was hypothesizing what I'd like. The fact that the static's increased, that's not great, so I'd need to do static baseline to static post, dynamic baseline to dynamic post, and then checking on the posts here as well to see if there are differences. Okay, so that would lead us to do 4 follow-up analyses, which is why I would then do 4 follow-up t-tests. Now, the choice of t-test, it would be consistent with within subject's idea. Because it was repeated measures within subject's ANOVA, we'd be doing repeated measures all within subject's t-test, which would be the paired samples t-test. So here's our means of standard deviations. And then over on the right-hand side, I've calculated Cohen's D. Again, just going to click on the cell here so you can see where I've got my values from. I've been playing around with effect size stuff because learning to use JASP a little bit more, wanting to know how JASP reaches some of its values. And what I've noticed is within JASP, for those of you who are using it, it calculates Cohen's D in a slightly different way. That's not a problem. You just need to know what it is and how that might alter or change the values were you to actually try and work it out by hand. So I'm still using the difference in the means, and all of Cohen's D's calculation still works out the difference in those means. Just what you use as your standard deviation is altering depending on the software that you're using. In some cases, JASP uses the pooled standard deviation, which is a different calculation which sort of works out the average of those standard deviations and then divides the difference between the two. Whereas with JASP, for paired samples t-test, it works it out by dividing by the standard deviation of the differences. SPSS actually gives us those standard deviations down here, so the mean difference divided by the standard deviation of those mean differences. What I'll say to you is I don't really mind. I just want you to work out what the effect size values are, and if we get discrepancies between different pieces of software, we can have that discussion in terms of how we report that. But Cohen's d, and if you look at any of the literature online, people acknowledge that there are multiple ways of doing it. So the only problem is when you're on the borderlines of between small and medium and large and so on and so forth, in terms of how you interpret that. What I tend to find is that when we look at the two different things, I tend to find that using the larger standard deviation is slightly more conservative. And what I mean by that is that the values are just a little bit smaller. Okay, so there's our effect sizes. So in terms of looking for a difference, they've got the two pre's up here, absolutely tiny value. And then that would imply that there's a trivial effect size because it's below 0.2. The two post values here, 0.1, which is again also below 0.2, so also happy to describe that as trivial. And then when we look at the dynamic, which is this third pair here, the difference is much smaller, so again trivial. So I'm just writing little notes alongside here, so I was trying to write a result section off the back of it. And then for the static group, as you can see that their completion time has gone from 5.399 to 5.567, well, that would be described as a small increase. So again, you could use these sorts of languages, this sort of wording and language when we're writing our future result sections. Come down to the t-test below, just move it across so you can see the different pairs I've put in here in terms of what we're looking at. So pre versus pre, post versus post, dynamic pre to post, and then static pre to post. Okay, there we go. Zoom that out a smidgen so you can actually see what I've written in here. There we go. And so here would be our results. I'll just stick on a little bit of formatting so you can see that I've got different lines between them. There we go, in terms of what the results are. So here's our different t-test results. No significant differences in the pre's, no significant differences in the post scores, although closing in on statistical significance at 0.05. No significant difference within the baseline group, but there is a significant difference in the static group. Now, when we're looking at those sorts of things, we would need to factor in Bonferroni correction, and that would be our classic 0.05. In this particular case, we've done 4 follow-up tests. Now that would mean that our Bonferroni correction would be 0.0125, and I'd round that to 0.013. So either way, statistically significant with this last particular result. So that means that statics time increased. That's not a good thing. Okay. So as I've been uploading some videos on the Moodle pages for you in terms of how to write up ANOVA. Again, I'll be copying and pasting these results over, and all I've written down here is just an extra little point in terms of that first paragraph where I'll be writing about the descriptive statistics. Okay. How's everyone doing? Got 25 people here watching the video. If anybody's got any specific questions in terms of the ANOVA, please let me know. If anybody's got any specific questions about the remote desktop or using JASP, stick those questions also in the live chat. I'm happy to try and answer those sorts of things as we go along. So just stick your points over here. I'm more than happy for you to contribute in terms of asking questions. What I do realise is that whilst I'm plugging away here and looking at some Excel stuff. You guys might have some questions in terms of what I'm looking at. So just let me know if I'm going too fast. Slow me down. I'm just sort of talking here at computer screen. It's quite unnerving in terms of working out whether you guys are with me or not. It's the difficult part of trying to teach online when I can't see your faces. Some of you pull very interesting faces when you're lost. In terms of, I can sort of pick that up in the room. So any problems, let me know, and I will slow myself down. Okay. So this was data set 1. Pretty much everything I think in terms of working our way through it, fairly logical. The ANOVA interaction is the reason why I did the 4 follow-up tests, because the interaction was indicating that they've slightly moved on in terms of how the groups have responded differently over time, and that's the hard bit in terms of working out what to do. Okay, so the second data set. Well, this one was the same experiment conducted in the same weeks as we were doing the sprinting, and this is the scientific inquiry students, so people included, giving us their sit and reach scores at the same time as they were doing their sprints. So it's the same research design, 2 variables, both repeated measures, testing completed across 2 different weeks with time with the variables crossed over according across those weeks. So same thing every single time. Start off by checking the distribution of your data with the flexibility stuff, everything falling much more within the plus or minus 2s than the sprinting data. So we're meeting those assumptions quite comfortably. So quite happy to move past those quite quickly. Shapiro-Wilk supports those same ideas. So happy days in terms of moving through. As I start to see some of the histograms following that bell-shaped curve, and as we look at the QQ plots again, though there appears a little bit of snaking, these points are actually quite close, and there's not that much deviation either end, and there's not too much sagging in the scores, which is sort of indicative of what you would see when your data follows a normal distribution. So scroll through the multitude of graphs, and we eventually start to come up on the ANOVA results. Okay, let me just zoom in a little bit for you. There we go. So same things, tricky bit, making sure that you set things up at the same point. That's always the hardest thing in the first place, to make sure that whatever it is you're doing, and it's not always easy. Hey Nikki, so remote desktop not working, was working for you last week, but it says that Surface is temporarily unavailable. I got that last night as well. Not 100% sure the reason why. What I did was I first of all went down to my start menu and typed in remote desktop and app, and made sure I hit update and refresh. And then mine said everything was working. Okay. And then I typed into the search button SPSS again to try and get it to load up. And it came up with the usual, do you want to connect? Which I did. And then it took half an hour to bother to open. It did eventually show up though. So my working habit at the moment is, if I want to do any SPSS work, is I sort of start it and then I go and have breakfast. And then I come back and check whether it's bothered to open in the meantime. And if it's not done that, I go and make myself another cup of tea. Okay. What I would then suggest was, since I was working through output and wanted to check whether the output I'd created had a significant difference, I have really started to lean on JASP a little bit, which is the other software package. So what I would suggest is that you go to JASP stats, and you could use this as a different version of statistics. It's free. You can download it, which is a massive help. And then so you can download it. So I'm on a Windows computer here, but there are other options. So there's different versions of it. So there's different versions for different issues of what we got here. So I'll be downloading this latest version because of the computer I've got. And then for the Mac users, what I found is that some of you, depending on, well, I say some of you, some of my first years as well, in trying to use JASP, a little bit cautious in terms of using it. And the App Store saying, oh, we won't allow you to use it because it's not from the App Store. You can change that in your settings. So you can set it up in your settings that you will actually still be able to open the file. And other people have got older versions of Macs, and what you need to do is you just need to go down and go and find which version of the operating system you've got. Some of you may be operating a Chromebook. If that's the case, downloading stuff, I'm less sure on because I've not used a Chromebook. But what I did suggest to somebody who then tried it for me was to try and run JASP within the browser. So what you'd need to do is register with Roll app, which I did. And then what you'd need to do is you need to give a Roll app access to one of your cloud drives. So I've got a Google Drive here as well. So I put a file onto my Google Drive and gave JASP Online access to it. And then it worked pretty much within the browser. So if you've got a computer that doesn't quite play ball with you in terms of using SPSS, or you're having problems downloading, you could always try and use it within the browser. This was a topic of conversation from the stats research methods and psychology meeting. So we're having Skype meetings between members of staff, and other members of staff are having problems with using SPSS. So you are not alone in terms of the problems. Okay, but as I said, it will eventually show up. It's just a case of when SPSS actually bothers to open. But what I'm finding is that if it doesn't work, and that's why I'm sort of creating videos for both of them, because I think JASP is a good thing to be using. And so far, with only some exceptions in CoINSD, I'm finding no differences in terms of what the output is giving to me. And I was contemplating at some point in terms of actually sort of moving some of the researching sport and exercise lessons onto JASP, but it's just a case of I wouldn't want to give you something I didn't have confidence in. Because I'm actually at home using it more often, my confidence levels in its output is increasing. So more than happy for you to use this. So when I finish creating your data for your results sections, more than happy for you to do all of your analysis in JASP. The only thing that you need to be able to do is you need to be able to export the file over into your Excel file. Will this video be available after the live stream too? Kira, I hope so. One of those things, I've been chatting here for just over 40, just coming up on 40 minutes. Don't think Google will cut me off. I'm hoping so. So hoping this will pop up in my YouTube page for you, and I'll make it a public file so you can access it. Okay. So any other questions, feel free to pop them up in the chat. I am looking at it. It's over on the one corner of my window. I just want to move on and talk about the other output in terms of what results we get from that. So same things to kick off with. Scroll past multivariate test nice and quickly. Check out the same findings from Horsley. Not run because we don't have enough conditions for it to run. and then we're getting the same output from the same locations that we would get them from before. So where the difference is between the output we've looked at previously, where it had different results across different places, all of our results comes into the same place or the same table. So warm-up was the main effect, time the main effect, and this time the interaction down here. So again, just in terms of presenting the results, in terms of them working out what it means. So 3 results, main effects for the types of warm-up at the top, no significant difference. And we're quite a long way away from being a significant difference, and our effect size is quite small. Now, in terms of the size of it, I'm going to flick on to my guidance here because I'm trying to remember all of them. 0.01 and 0.06 for partial letter squared. So it would be classified as a small effect if we were to write it down. Now, when it comes to non-significant findings, I don't write the effect size description down here, so I'm not going to write there was no significant small effect. It wouldn't work. So it's better to just write that there was no significant effect, report the results, and then the reader, knowing what criteria you're using, can go, okay, if I need to compare this to my own study or the literature I've read, can work out that it's a small effect. So no main effect finding. And then this is the other finding, which is for time. Now our F value is large, our effect size is large, and we're statistically significant. So that would give me some confidence that the time has had an effect, which means that there's a difference from pre to post. Now that difference from pre to post is regardless of which type of warm-up. So if you did a warm-up, your sit and reach distance is different. Then our results here for the interaction. Now, this is the reason why I wanted to give you this data set. Because at some point, what I realize in terms of lots of my teaching, I give you results, and lots of times that they're significant. But how do we deal with it when results are not significant, which happens more often than you would think? So in this case, not significant by quite some margin. And then our effect size value also really, really small. So not significant. So this would be the tricky bit in terms of planning what follow-up tests to do, or in fact, whether we need to do any follow-up tests. So what we know is that there's no difference between the warm-ups, regardless of time. But there is a difference between baseline and post, regardless of which warm-up. So it doesn't matter which warm-up you were doing, it's led to a difference. And this interaction effect being not significant means that the warm-ups had the same response. So they've either both increased or both decreased or whatever it might be. So to try and get your head around this, you need to scroll down and have a look at the graph. Now, again, the blue line, which is the top one, is the dynamic warm-up, and the static one, which is the green one, which is the bottom one. Okay, now the 2 data points at the pre, the 2 data points at the post, really, really close together. And what that means is not difference. If you're looking about what we said with the ANOVA, there was no significant difference between the warm-ups. And you can sort of see that in the graph in terms of how close they are. If you look here in terms of this as being a value of 8, and that's about 8, and that would be about 7.8, and I can sort of scroll up and have a look at that. Yeah, warm-ups to start off with 1 and 2. Yeah, 8s, 7s, 10s, and 10s in terms of what the values are. So the values are really, really close together. So there's no difference between the warm-ups. But if we then look pre to post, well, we're then starting to see difference. We go from 8 to 10 and 7 to 10. So they've had the same response, which means that there's no interaction effect. Now, this was something we chatted about in the very first week in terms of how you look at those interactions. And we were drawing out some graphs, and I'll scroll here in my windows here in terms of what an interaction is and what a not interaction is, or a non-interaction. So this was the sort of the drawing we had for the sprints where the two groups crossed over. And here's some of the sort of interaction graphs we were looking at for either the FMS data or looking at for the diabetes mellitus data. So what we need to consider is what this actually means for us in terms of how we move forwards. Whereas down here we've got tram lines, and those tram lines are indicative that the groups have had the same response. So we're pretty similar to this particular graph. So how would I choose to follow this up? Well, what I've done is sort of like, I wanted to sort of show you what happens when you do stuff. But what I would actually be doing at this stage is actually going, well, what do I need to do? The ANOVA said there's no difference in warm-ups. I can believe that. We've only got 2 groups and there's no difference. The ANOVA said there's a difference over time. I can believe that. But then there's no interaction effect. So what I've got below is the same 4 t-tests I would have done last time, or different sprints. But the reason I did them was to show you where there would not be differences and how the findings are actually the same. So here's our mean values. Here's our standard deviations. And over here on the right-hand side, the Cohen's d values. Notice how they're either trivial or small in terms of very differences. Now, I'll be honest with you, I've managed to click the buttons in a slightly different order this time. So this one is dynamic pre to post, static pre to post, which is the time variables. So it was significant for time, which is the reason why I chose these 2 first. So the ANOVA above said significant difference of time, so I'd want to be able to do that analysis down here. These are the ones that are comparing the 2 warm-ups against each other. I've put these in here to sort of make the point that the ANOVA said there was no difference. So we come down to the t-test results down below. Values over here on the right-hand side. Make those a little bit bigger so you can have a look at them. And then just make this all a little bit easier to read by sticking some borders in there for you. Okay, so the first one is the dynamic warm-up, pre to post, small significant effect. That's completely the same as what the ANOVA said. So did I really need to do this? Here's the one for the static warm-up, same finding. There's a significant difference from pre to post, which is the same finding as the ANOVA. So did I really need to do this test? And then these 2 results down here are static versus dynamic pre and static versus dynamic post. No significant difference between the warm-ups, which is what the ANOVA said. So I definitely did not need to do these. Now, I did at the start just want to check that these would be sort of the same. So I did these as like reassurance, or for myself in terms of, well, what happens if one group was significant but the other group wasn't quite significant? So I'll just sort of put these 2 together just as sort of like a little confidence builder for me, in terms of knowing that what I saw in the ANOVA was actually being supported by those t-tests. So what we found is that both warm-ups led to a small increase in sit and reach difference. So I'm applying that small from up here, where I've looked at the Cohen's d values to indicate that one, and the dynamic one was a small increase, and we're closing it on 0.2, which is the criteria for Cohen's d. Okay, again, look to use all of the comments I've written down here, and although I can realise that that's not subscripted across nicely, this would be what I'd be copying and pasting over into results sections. Okay, all right. That's me pretty much chatted through 2 outputs. The point I wanted to make was that you don't always make the same decisions each and every time with all of the ANOVAs. And with this flexibility one, you could argue that I didn't need to do those follow-up tests. because the main effect told me where the differences were, and because the interaction was not significant, I didn't need to do those follow-up tests to actually try and track down where the differences were. Whereas with the sprinting one, those differences were there, and that's the reason why I did those follow-up tests. Okay, so closing up on time, what I'll do is I'll double check that this stream gets saved online. If you've got any questions following on from this stream in terms of didn't quite work for you, or you've got any comments or feedback in terms of how to improve this, more than happy to try and support you with what it's doing. Just as a reminder, I'm still working through your data sets and your results sections. Did 3 yesterday in terms of what I'm doing. It's going okay. I wish I could go a little bit faster, but ho-hum, it is what it is. So if one of your groups not sent me anything yet about the data that you were planning to use, or so on and so forth, could you upload it into the groups bit that I created on Office 365? Just upload whatever files you've got there. I'll give credit to Max and James and Cam and Liam, who sent me a couple of files where their method pretty much copies stuff. That made it so much easier for me in terms of creating the data set, because it gave me something to start from, and all I needed to do was just add on some physical characteristics for the participants. So that was just a really easy data set for me to create. The ones where I'm sort of guessing based upon what I read, based upon what I think's in your method, just a little bit harder. So if you could send me through something, it makes the world go around a little bit faster. And I think we've all got a little bit of extra time on our hands at the moment. So send it through, see if we can get this churned out any faster. Okay, thank you for your time. I'll say it because all YouTubers say, leave a like and a comment down below. And if you enjoyed what you saw today, think about subscribing. Thank you very much for your time. See you all later. And I might try and do another live stream next week if you think that was positive. So leave a comment in terms of whether you think that would be a good thing and whether it worked for you or not. Cheers. See you later. Have a good day.